Hey everyone, we're going to do one more day of limits, so let's get to it. Let's go dashing right through it. Alright, so again we said we're going to do a little bit more with limits. Today we're going to evaluate limits algebraically. Alright, easiest way to evaluate limits algebraically is to do what's called direct substitution. If we're going to do direct substitution, that means we're going to take the value that the x is approaching, put it in place of the x inside the function, and evaluate the expression. So if we have this limit here, which is the limit as x goes to 1 of this fraction, that means we're going to try to do with direct substitution, take that 1 and put it in place of all of those x's. So that would give us 1 squared minus 4 times 1 plus 4, all over 1 minus 2. Then we would simplify. 1 minus 4 plus 4, we'd end up with 1 over negative 1, and we'd get a negative 1. Alright, let's try again. If we tried again with one like this with direct substitution, with this one the limit as x goes to 2, x squared minus 4x plus 4 over x minus 2. So if we put 2 in for the x's, we'd get 2 squared minus 4 times 2 plus 4 over 2 minus 2. Alright, so up top 4 minus 8 plus 4, down low 2 minus 2 is 0. And that's going to be a problem for us because we can't do division by 0. Division by 0 is undefined. Alright, if we take a look at that though, that fraction, the x squared minus 4x plus 4, that's factorable. Factors of, this is the 1x squared plus bx plus c, so we'd look for factors of c that add to b. Factors of positive 4 that add to negative 4. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So factors as x minus 2, x minus 2. And then one of those x minus 2's in the numerator would cancel with that x minus 2 in the denominator. So we could now do the limit as x goes to 2 of x minus 2. Direct substitution, put that 2 in, we get 2 minus 2, and we do get 0. Alright, so if we try direct substitution and it gives us a 0 on the denominator, we might need to try to simplify or possibly unsimplify the expression before we can use our direct substitution. Alright, so we have some problems that we're going to try right here. Alright, so we have our limits up here on the board. Let's see if we can evaluate these with direct substitution, just taking the value that x is approaching and putting it in place of the x's. So that would give us negative 1, and then inside negative 1 minus 1, quantity squared, turns into negative 1 outside, negative 1 minus a 1, that's going to become a plus a positive, minus a 1. This becomes plus a negative. Said that wrong. We get a negative 2 inside, which we're going to square. Negative 1 times 4. We're going to get a negative 4 there. Alright, let's try our next one. Again, we'll see if we can just do direct substitution. Let's just put the value of 2 in place of the x. We'd end up with 2 plus 5, and that's all we can do with that one. Alright, and then here, limit as x goes to 0, so let's go and put the 0, see if direct substitution works. Put the 0 in place of the x's. We'd have e to the 0, and then sine of 0. Oh dear, we haven't done those kind of things in a while. But let's see, anything to the 0 power is going to be a 1, and then we haven't done sine, cosine, tangent in a while. Sine refers to from our unit circle to the y values, and we are at 0. So if we're thinking our unit circle, we're over here at 0, and on our unit circle, the y coordinate pointing straight out here is also 0. So that's going to be 1 times 0, which is 0. Alright, and then one more. Let's try direct substitution again. We're going to take this value that x is approaching, which is pi, and put it in place of the x. So we'd have natural log of the sine of pi over 2. We just said that sine was the y-coordinate, and we're at pi over 2, so we're pointing straight up. All right, we are pointing straight up. If we are pointing straight up on our unit circle, the y-coordinate is actually a 1. All right, so that would be the natural log then of 1, and the natural log of 1 is going to turn out to be 0. All right, so those ones all worked with direct substitution. All right, so let's try a couple more, see what happens. All right, so here's our next one. Every time we're going to try to evaluate limits algebraically, we should always first try direct substitution. And this is the limit as x goes to 3. So if we're trying direct substitution, we'd have 3 squared minus 9 over 3 squared, 2 times 3 minus 15, 9 minus 9, 9 plus 6 minus 15, all right, problem because again, we cannot do division by 0. So we have a rational function. Maybe we can do some factoring. All right, maybe we can do some factoring. That numerator, x squared is a square, 9 is also a square, subtraction between. So that should factor with our difference of squares pattern. And then in our denominator, again, this is the easier case where it's a 1x squared plus 2x plus, 1x squared plus bx plus c. So we're looking for factors of c that add to b, factors of negative 15 that add to positive 2. That's going to be plus 5 and minus 3. And then in there, we do have that common factor right there. All right, so we can say that this is the same thing as then the limit as x goes to 3 of x plus 3 over x plus 5. And then now we can try direct substitution. And then now when we try direct substitution, we get 3 plus 3 over 3 plus 5, 6 over 8, and we can reduce and get 3/4. All right, so our next one, we're doing the limit as x goes to negative 1 of x cubed plus 1 over x plus 1. Let's again try direct substitution.
We do that. Negative 1 cubed plus 1, negative 1 plus 1. Negative 1 cubed is negative 1 plus 1 over 0.
We have a 0 down low again, so we've got a problem. You might, we factored with the last one. Let's see if we can factor with this one. There is a factoring pattern that you could use for this numerator, x cubed plus 1. It's one that I never bothered to memorize because I remember how to do synthetic division. We are hoping that we are going to be able to cancel out this x plus 1. So let's see if we can divide that out with synthetic division. We would take the 0 of this divisor and put it into our little box. The 0 of this is negative 1. Then we would need to make sure that we have every place represented. Here's 1x cubed, 0, x squared, 0, x, and then plus 1. All right, our synthetic division, we first bring down that number. We multiply by the 0 of our divisor. Negative 1 times 1, negative 1. Add down, multiply by the 0 of your divisor again. Positive 1, add down, multiply by the 0 of your divisor again. Negative 1, add down, and we get a remainder of 0. All right, so that meant that x cubed plus 1 is the same thing as whenever we're taking a 0 and writing it as a factor, it's minus a negative. All right, so that would have been x minus negative 1. And then this here, x squared minus x and plus 1. Which we can then rewrite plus 1 right there. Okay, so we were doing the limit as x goes to negative 1 of x cubed plus 1 over x plus 1. We found out that that was equivalent to that x plus 1, x squared minus x plus 1 all over x plus 1. So we can cancel here. And then we can go ahead and do our direct substitution. Just rewrite that first before I do. All right, and now I'll go to our direct substitution, putting that negative 1 in. Negative 1 squared minus negative 1 plus 1. Negative squared becomes positive. Negative times negative becomes positive. And then plus that other 1, we get 3. All right. So this one should be just like that last one. We're first going to check it with direct substitution.
We have 2 cubed, 2 times 2 squared, plus 2 minus 2, a lot of 2's, over 2 minus 2. We have 8. 2 squared is 4, times another 2 is 8. It was minus, and then that 2 minus 2 is going to 0 out right there, and 0 down low.
0 over 0. Again, we cannot have 0 in our denominator. I can't factor this by regular means, but we can factor it with the aid of synthetic division, hoping that we can divide out this x minus 2. So we're going to take the 0 of this divisor, x minus 2, the 0 of that, what's going to make that 0? 2. All right, goes in our little box, and then we spread out our coefficients, making sure every degree is represented. 1x cubed minus 2x squared plus 1x minus 2. So every degree was represented there. Bring down your 1, multiply by your 0, multiply by your 0, 2 times 0 is 0, bring down, multiply times your 0, 2 times 1 is 2. All right, add down, we get a 0, which was our remainder. So it does divide out. So that x cubed minus 2x squared plus x minus 2 is going to be equal to x minus the 0, and then what is this? It was cubic. And we divided one linear factor out, so it's going to become quadratic. All right, we can just leave off that 0x, so x squared plus 1. Okay, so factored the numerator. We have that repeated factor down low. That repeated factor that was down low and up top. All right, that common factor. So we canceled it out. So we're left with the limit as x goes to 2 of x squared plus 1. And then looks like we can do our direct substitution. Now we get 2 squared plus 1, 4 plus 1, we get 5. All right, here we go again. Always going to first try direct substitution. Let's just put that 3.
We have a 0 up top, down low. 4 times 3 is 12. 12 plus 4 is 16. It's inside a square root. Square root of 16 is 4, so we're 4 minus 4.
0 down low, which is a problem for us. All right, if we think about what we did with the last couple of problems, those were rational expressions, and we factored and then canceled, so we simplified. This is not rational because we have a radical down here, but maybe if we think about, we're not typically supposed to be leaving radicals down low. Maybe we can get that radical out of the denominator. All right, how do we get that radical out of the denominator? Hopefully remember what it is that we need to do. We're going to have to multiply. We're going to have to multiply the top and bottom by the conjugate of the denominator. What's that conjugate going to be? What's that conjugate going to be? All right, same thing, except we changed the symbol in between. All right, so it was originally minus, now we're using addition in between there. All right, so now it might look like a mess, but we have to FOIL. All right, we have to FOIL limit as x goes to 3. All right, when we FOIL, all right, first, so x times that square root outer 4x inner negative 3 square root of 4x plus 4 and last negative 12 minus 12. Okay. Down low, again, FOIL. When you multiply a square root times a square root, multiplying actually the square root by itself, all right, you're going to get that quantity squared, so it's going to cancel out the square root. We're left with just 4x plus 4, outer, inner, and last, the numerator, nothing cancels out right away. In the denominator, though, we have these two pieces right here, which are the same, just opposite symbols, so they'll zero out. I do have the same radical right there in the numerator. I have that same radical right there in that numerator. So I'm going to rearrange those pieces. X, 4x plus 4 inside the radical, minus 3, 4x plus 4. And then outside the radical was a 4x and a minus 12. And then down low, we're left with 4x plus 4 minus 16 is a negative 12. Okay, so let's, since we have the same thing right here, that same radical right there, let's do some factoring by grouping. Limit as x goes to 3. Both of those pieces have that same radical, so when we factored the radical out, we were left with x minus 3. Okay. And then actually when we have these next two pieces right here, they have a common factor of 4. if we factor the 4 out of those two pieces, oh, look at that. Our two main sets of parentheses there are the same. And then also, this denominator, we could factor a GCF. And that denominator, we can factor a GCF out. All right, that GCF factored out, 4x minus 3. All right, so that's going to help us. That common factor, those parentheses, jumps all the way to the front. And then inside the next set, okay, our common factor, and now we can try direct substitution again. 4 times 3 plus 4 plus a 4 outside, all over 4. 4 times 3 is 12. 12 plus 4 is 16. Square root is 16 plus 4 over 4. So that's 4 plus 4 over 4, 8 over 4. All that to get the number 2. All right, last one. Again, we have a radical. This time the radical is in the numerator instead of the denominator, but let's still try direct substitution.
Six minus 5 minus 1 over 0, that's probably going to be a problem. 1 minus 1.
Yep, 0 down low. All right, so let's reset. All right, so last time we simplified by getting the radical out of our denominator. And we did that by multiplying the top and bottom by the conjugate of the denominator. Well, this time the radical's in the numerator. Maybe we can do the same thing, multiply by the conjugate, except that it was the conjugate of the numerator. So this time we're unsimplifying. So let's see if maybe we can unsimplify this to put the radical back down low. Alright, so multiply top and bottom by the conjugate of the numerator this time. Alright, because we're trying to unsimplify this, put the radical back down low, and maybe that will help us. So we'll FOIL again. Alright, first, alright, so we're multiplying the radical times itself, so that's going to get rid of the radical and leave us with just what was inside, 2x minus 5. That was the first. Here's the outer. Inner. And then last, minus 1. And then down low, first. Outer, inner, and last. All right, if you take a look at the numerator, those two pieces zero out. So we're left with 2x minus 5 minus 1 in our numerator. Our denominator, put the common pieces, the parts that had something in common, closer to each other. Okay. I can simplify a little bit in that numerator. Minus 5 minus 1. Minus 5 minus 1 becomes a minus 6. And then down here, let's do some factoring by grouping again. We have that same radical right between these two pieces right here. So let's factor that radical out of those two pieces. Leaves us with then x minus 3 from the other part of what we factored. And then right here is also an x minus 3, which is what was in that set of parentheses here. So not a GCF that we can really factor out here, but you can remember always, always, always factor a 1 out. So let's factor a 1 out of that so that we do have the same set of parentheses there. Okay, so in our next step, this numerator, there's a GCF of 2. And then the x minus 3 that was here and here jumps all the way to the front, leaving us with a square root of 2x minus 5 and a plus 1. Our x minus 3 quantities cancel out. 2 up top. And now let's try direct substitution. So we're at 2 over 2 times 3 minus 5 plus 1. 2 times 3 is 6. Minus 5 plus 1. Square root of 1 plus 1. 2 over 1 plus 1. 2 over 2. And we get a 1. All right, so I think that was going to be our last day with limits. So remember we said we would always first try direct substitution. If direct substitution gives us a 0 down low, see if you can factor to cancel. If it was not a rational expression, if it had a radical in there, maybe we need to move the radical from the top to the bottom or from the bottom to the top by multiplying the top and bottom by the conjugate of whichever part had that radical in there. All right, so that's it. Have a good day.